Good morning, students. Today we will solve few more problems on the topic current electricity. Right? So take down the third question. What is the main current in the circuit? Right. So this is the given circuit. So we need to find the current which is flowing from the circuit. Right. So here two resistors which are connected. So two resistors are connected in parallel, and here one resistance and one capacitor. These two are connected in parallel. So here we need to remember is the capacitor will block the current. That one is the DC current. Right. So current which is flowing through the capacitor, it is blocked by the capacitor. So capacitor blocks the DC current. That means there is no flow of current through the capacitor, right? So only we have the two resistance and one resistance. That is two resistance which are connected in parallel, and one resistance is connected in series with these two resistors, right? So first, to find the total current I, right? So we need to find the total current I. In the circuit, they given the voltage 10 volt, and we have the three resistance. So right, so naming these resistance as R1, R2, and R3, right? So first we need to find the equivalent resistance of all these three resistance, right? So first we need to simplify the two resistance which are connected in parallel, right? So that means resistance R1 is parallel with resistance R2, right? So resistance R1 is in parallel with the R2, right? So the effective resistance of these two resistance, we have the formula 1 divided by Rp, right? That is equals to 1 by R1 plus 1 by R2. So 1 by R1, we know the value of resistance R1, that is 1 by 20 plus 1 by 20, right? So denominator same, so we can directly add 2 by 20, that is 1 divided by RP. So 2 ones are 2 tens are, right? So the equivalent resistance of the parallel combination is 10 ohm, right? So now we can write this one as so this is Rp, right? Equivalent resistance of these two resistance. So we get that one as 10 ohm. So this is R3 as is, that is 20 ohm, right? So the current which is flowing I. So voltage is 10 volt. So I already mentioned there is no flow of current through the capacitor, so hence we can neglect the capacitor, right? So now observe Rp and R3 are in series, right? So Rp and R3 are in series. To find the equivalent resistance of these two resistors which are in series, we have the formula Rs, that is equals to here Rp is the one resistance plus Rp. Sum of two resistance, we get the equivalent resistance in series. So Rp is 10 plus R3 is 20, we get 30 ohm. Right? So this we can write 10 volt current I. So this is Rs, that is equals to 30 ohm. right? So we reduce the circuit from complex to simple. That is equivalent circuit of the given circuit is in this form, right? So that is RS is the equivalent resistance of these three resistances, right? So here, from here we can find the total current which is flowing in the circuit. From the Ohm's law, V is equals to IR, right? So V the given 10, we need to find the current I, and we have the resistance 30, right? So I is equals to 10 by 30. So I is equals to 0.33 amperes. So this is the final current which is flowing in the circuit, right? So here we get 0.33 amperes, right? So this is simplification. So in exam there is no need to draw these diagrams. So directly we can simplify. So these two are in parallel. First, we need to find the equivalent resistance of these two resistances, right? So we get the resistance Rp. Next, here the equivalent resistance is in series with the third resistance. Then we have the formula Rp plus R3, 10 plus 20, 30. So we get one final equivalent resistance, 30 ohm. So current which is flowing through the 30 ohm, we need to find the given voltage 10 volt. So I is equals to 0.33 amperes, right? Next. Three resistors, 2 ohm, 3 ohm and 4 ohm are connected in series, series. What is the total resistor? What is the total resistor of the combination of the combination? If the combination, if the combination, if the combination is connected to a battery, is connected to a battery of EMF 10 volt and negligible internal resistance, then obtain potential drop across each resistor. Right. So this is the question. So in the question they given three resistors. That means resistance. They given three resistors. One is 2 ohm, 3 ohm, and 4 ohm, and all the three resistors which are connected in series. Right. So this is the symbol of the resistance, right? So taken R1 is equals to 2 ohm, they given R2 is equals to 3 ohm, and R4 is R3 is equals to 4 ohm, right? So these three resistances which are connected in series. So the first question, to find the total resistance of the combination. That means we are going to find the equivalent resistance of these three resistance, right? So equivalent resistance RS, that is effective resistance, or equivalent resistance RS, that is equals to R1 plus R2 plus R3, right? So they given three resistance, 2 plus 3 plus 4, 5 plus 4, 9. So this is the total resistance or effective resistance, right, or equivalent resistance. The total resistance means same, effective resistance means same, and the total resistance, effective resistance, and equivalent resistance, all the three terms are same, right? So from the formula, all the three resistances are connected in series. We have R1 plus R2 plus R3, right? So next, if the combination is connected to the battery of EMF 10 volt, so this combination is connected to the battery which having the EMF 10 volt and negligible internal resistance. That means small r is equals to 0. Either we can write or we can neglect that one, right? Next, we need to find the potential drop across each resistance. So when the three resistances are connected in series, then the potential drop across the three resistance, that is V1, V2 and V3. So series ಅಲ್ಲಿದ್ದಾಗ ನಮಗೆ voltage ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, divide ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So we know the formula from the Ohm's law, V is equals to IR. So in series the current remains same. For all the three resistance, the current which is flowing is same, right? So to find the potential drop across the first resistor, the current is same in all the resistors. So we know the value of R1, but we don't know the value of I. So first we need to find I, right? So we need to find the I by using the equivalent resistance, right? So from the Ohm's law, V is equals to I RS, right? So voltage, that is 10, that is equals to I into RS value is 9, right? So I is equals to 10 divided by 9. So 10 divided by 9 is 1.112 amperes. So this is the current which is flowing through the circuit. So equivalent resistance means these three resistance which are equal to a single resistance. So that resistance value is RS is equals to 9 ohm and the voltage is 10 volt. So in this we find the current I. So ಇಲ್ಲಿ ನಮಗೆ ಏನು current flow ಆಗ್ತಾ ಇರುತ್ತೋ same current across the three resistance ಕೂಡ flow ಆಗ್ತಾ ಇರುತ್ತೆ. Now we get the value of I, so we can find the potential across the each resistance. So potential across the first resistor V1, that is equals to I is 1.112 into resistance R is 2, right? So V1 is equals to 2.224 volt. So this is the voltage drop across first resistor. So same as V2 is equals to 1.112 into 3. So V2 is equals to 3.336 volt, right? So this is the potential drop across the second resistor, and V3 is equals to 1.112 into 4, right? 4.448 volt. So if we add all these three, we get finally 10, right? So 2 plus 3, 5. So 5 plus 4, 9. So 9.99 something we are getting, that is approximately equals to 10 volt, right? So these are the three potentials across the three resistors. So now the other problem solve ಮಾಡಬೇಕಂದ್ರೆ formula very important. So without formula, if we simplify means we get 0 marks, right? Next problem. So fifth one. Find the effective resistance across A and B in the following figure. So equivalent resistance, effective resistance, total resistance, so all are same, right? This point B and here point A. So we need to find the equivalent resistance between A and to that of the B. So the given values 6 ohm, here 3 ohm, 6 ohm, 9 ohm, 4 ohm, 5 ohm, 10 ohm, 15 ohm, and again here 6 ohm, right? So this is the given circuit. So here we need to find the equivalent resistance. So here almost we have 3, 4, 5, 5 plus 4, 9. Total line resistance. We need to convert this to a single resistance. So that resistance is what we call, that one is the effective resistance or equivalent resistance, right? So we need to simplify all these three resistance to get one single resistance. That means effective resistance means single resistance which will do the same work as all these three resistance will do, right? So now observe here, this circuit is a combination of both series and parallel, right? So here from A, so naming these resistances first R1, R2, R3, R4. So your convenient, you can choose any numberings, right? So R5, R6, R7, R8, and R9, right? So now, if you observe this, so R2, R3, and R4, these three are parallel. So parallel series and we have one resistance, one end of the one resistance is connected with the another end of the another resistance, and leaving the two ends remains as is. So only one end of the two resistors join ಮಾಡಿದ್ರೆ ನಮಗೆ ಏನು ಸಿಗುತ್ತೆ series combination ಅಂತ ಹೇಳ್ತೀವಿ, right? So ಇಲ್ಲಿ ನಮಗೆ ಕ್ಲಿಯರ್ ಇರಬೇಕು ಯಾವುದು ಸೀರೀಸ್ ಇರುತ್ತೆ ಯಾವುದು ಪ್ಯಾರಲಲ್ ಇರುತ್ತೆ. ಸೊ ತಗೋಬೇಕಾದ್ರೆ ಸ್ವಲ್ಪ ವೇರಿಯೇಷನ್ ಆಯ್ತು ಅಂದ್ರೂ ಕೂಡ ಏನಾಗುತ್ತೆ ನಮಗೆ ರಾಂಗ್ ಆಗುತ್ತೆ. ಸೊ ಸೀರೀಸ್ ಅಂದ್ರೆ ಏನು, one end of one resistance is joined with the another end of the another end of the another resistor, right? So only one end is joining together between the two resistors means, so that type of resistor we call as series combination. So only one end join ಆಗಿದ್ರೆ ಮಾತ್ರ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ series, right? So both the ends join ಆಗಿತ್ತು ಅಂದ್ರೆ ಅದು ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬೇಕಾದ್ರೂ ಇರಬಹುದು, right? So now observe here, so these are the two resistors. So ಈ ಎರಡು resistors ಅಲ್ಲೂ both the ends of the resistors are joined together, right? So ಈ case ಅಲ್ಲಿ only one end is joined with the another resistor. So here both the ends of the two resistors are joined together, then this combination we call that one as the parallel combination. So ಎರಡು end ಕೂಡ join ಆಗಿತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ನಾವು parallel ಅಂತ ಕರೀತೀವಿ. Only one end join ಆಗಿತ್ತು ಅಂದ್ರೆ ಅದನ್ನ series. So ಇದು ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬೇಕಾದ್ರೂ ಇರಬಹುದು, right? To find the effective resistance, R2, R3 and R4 are in parallel, right? To find the effective resistances in parallel, we have the formula 1 divided by Rp, that is equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Right? So here we have R2, R3, R4. So we can write as this R2, R3, R4. Right? So 1 divided by R2 is 3 ohm plus 1 divided by 6 plus 1 divided by 9. Right? So if we take the LCM here, right? So LCM 18 is the LCM. So 3, 6 are 18, 6, 3 are 18 plus 9 2 are 18. So 9 plus 2, 11 divided by 18. That is 1 divided by Rp. So we need Rp, right? So Rp is equals to 18 divided by 11. So 11, 1s are 11, right? So 1.116 are 66, right? So 1.6 and it further continues, right? So 1.63 ohm. So this is the equivalent resistance of these three resistors which are connected in parallel, right? So now we can write this here. Starts from A to R1, this becomes Rp, right? So R1 is 6 ohm, so Rp is 1.63 ohm, right? So again 4 as is, that is series 4, so that one is R5, right? Now observe here. So here also the same combination. So R6, R7 and R8 are in parallel. So ಎರಡು ನೆಟ್ವರ್ಕ್ ಅಲ್ಲಿ ಪ್ಯಾರಲಲ್ ಇರೋದ್ರಿಂದ ಒಂದು RP1 ಅಂತ ತಗೊಳ್ಳೋಣ, ಇನ್ನೊಂದು RP2, right? So 1 divided by RP2 is equals to 1 divided by R6, 1 divided by R7 plus 1 divided by R8, right? So substitute the values. 1 divided by 5 plus 1 divided by 10 plus 1 divided by 15. So if we take LCM here 5, 10, 15, so almost we get 30, right? So 5 6 are 30, so 10 3s are 15 2s are 30, right? So 6 9 plus 2, 11 divided by 30. So we get 1 divided by Rp2. So Rp2 is equals to 30 divided by 11, right? So we get 2.72 ohm. So if we simplify that value, we get 2.72. So this is, we get the effective resistance of these three combinations, right? So that one we can write here. So this is Rp1, here Rp2, so we get 2.72 ohm, and the last one is 6 ohm, that is R9, right? So first resistance, now if you observe here, all the resistance are in series. So only one end of the resistance is joined with the another end, right? So if you observe all the 4 resistors, 1, 2, 3, 4, 5, all the 5 resistors are in series, right? So now the effective resistance RS, R series, that is equals to R1 plus RP1 plus R5 plus RP2 plus R9, right? So all the 5 resistors are in series. So simply we add, we get the value 6 plus 1.63 plus 4 plus 2.72 plus 6, right? So almost we get 20.35 ohm. So this is the equivalent resistance of the circuit, 20.35 ohm. That is the effective resistance of the overall combination, right? So that is right here. 6 ohm. All these three combinations we get the value 1.63. Here it is 4 as it is. All these three combinations we get the value 2. And 6 ohm, right? So if you observe here 6, 1.63, 4, 2.72 and 6, all these three resistances, all the 5 resistances are in series, hence RS is equals to R1 plus, RP1 plus, R5 plus, RP2 plus, R9. So we get the value 20.35 ohm, right? We go to the next problem. 6th one. In the given circuit, calculate. So in the first one, effective resistance between A and B. So in the second one, current through the circuit. And the last, current through 9 ohm resistor. Current through 9 ohm resistor. So the circuit the point is A1 6 volt, 6 volt and 9 volt, right? So this is the given circuit. So here we need to find the effective resistance between these three resistances. So if you observe here 3 ohm resistance and 3 ohm resistance, these two are in series. So 6 ohm and 6 ohm, these two are in series, and all these three resistances are in parallel, right? So first we need to find the effective resistance between A and B. So naming these resistances as R1, R2, R3, R4 and R5, right? So now in the first one, right? So R1 and R2 are in series, right? So these two are in series. RS1 we have the formula R1 plus R2, 3 plus 3 we get 6, right? We can replace this by single resistance, that is RS1, that is equals to 6 ohm, right? So in the same way, R3 and R4 are in series. So RS2, that is equals to R3 plus R4, that is 6 plus 6, that is equals to 12 ohms. So these two resistances are in series. So we get the equivalent resistance RS2, that is equals to 12 ohm. Right? So now 9 ohm as it is. R5 is equals to, right? So now RS1, RS2 and R5, all these three resistances are in parallel, right? So RS1, RS2 and R5 are in parallel. So we need to find the equivalent resistance for parallel combination. 1 divided by Rp, that is equals to 1 divided by Rs1, 1 divided by Rs2 plus 1 divided by R5, right? So 1 divided by Rs1 is 1 by 6 plus 1 by 12 plus 1 by 9, right? So if we take the LCM here, so 6, 9, 12. We get the LCM. So 6 6 are 36. So 12 3s are 36. So 9 4s are 36. So we get 13 divided by 36. So 1 divided by RP. So we need RP. So RP is equals to 36 divided by 13. Right. So this is, we get the equivalent resistance between A and B, that is RP, that is equals to 36 by 13 ohm. So this is for the first one. So further we can simplify 36. If we divide by 13, we get some value 32 point something. We get the value. Either we can write in decimals or we can write in the fraction itself. So this is what the equivalent resistance between the 2 points A and B, right? So next, current through the circuit, right? So current through the circuit. So this equivalent resistance, so this combination of resistance we can replace by the equivalent resistance, right? So here we connected to the same battery of 10 volt. So current flowing is, so not 10 volt, it is 3 volt, and they given the internal resistance 0.24 ohm. So we need to find the current I. So ಇಲ್ಲಿ current flow ಆಗ್ತಾ ಇರುತ್ತೋ, the same current is flowing there also, right? So from the formula we have the relation V is equals to I R. So here RP is the resistance, right? V is equals to IR. We need I. So here RP is equals to I RP. So I, for the internal resistance, we have the formula I is equals to ERP divided by RP plus small r, where small r is the internal resistance and the value is 0.24, right? So the value of RP 36 divided by 13. 2.76. So we get this value as 2.76 ohm, right? So here E value is 3 volt into 2.76. Here it cannot come. So E divided by RP plus R. Here only we are going to calculate the current, right? So if I put R means we get voltage. 3 divided by RP is 2.76 plus internal resistance is 0.24. So if we add these two, we get 3 divided by 3. So the current flowing through the circuit is 1 ampere. So this is for the second one. So the current flowing in the circuit, that is 1 ampere. The formula is I is equals to E divided by Rp plus R. So Rp value is 2.76 plus internal resistance is 0.24. If you add these two, we get the value 3. Right? So now, and the last one is the current through 9 ohm resistance. That means here the current is dividing I1, I2, I3. So in parallel combination, current divides, right? So we need to find the current which is flowing through the 9 ohm resistance, right? So in parallel combination, the potentials remains same, right? So first we need to find the potential for this combination, right? So we have the current and we have the resistance. So V is equals to IR. So V is equals to IRP. So voltage for the total combination or equivalent resistance. So we get I current is 1 ampere and the resistance is 2.76. So voltage we getting is 2.76 volt. So this is the voltage across this combination. So in all these three combinations, the voltage remains same. So that voltage is 2.76. So across this combination also we have the voltage 2.76 volt. So across this combination also we have the same voltage because in parallel the voltage remains same, right? So here we have the voltage and resistance, so we can easily find the current, right? So V is equals to I3 or 5, right? So we are going to calculate the current which is flowing through the 9 ohm resistance. So that is I3. So voltage V is 2.76 divided by 9, right? So I3 is equals to 0.3. So 0.27, that is 0.93 amperes. So this is the current which is flowing through the 9 ohm resistance. So if they ask for the current flowing through 6 ohm resistance means again here the voltage remains same. So voltage divided by this combination, right? That is divided by 12. 2.76 divided by 12. So that gives the current I2. And also here also. So 2.76 divided by 6, we get the current I1. So if we add all these currents, again we get the I, that is 1 ampere, right? So remaining problems we will discuss in our next class, right? Thank you.